method. First and foremost, have you all noted down the second point? Okay, good. First, I'll quickly see what you mean by liquation. What is the word? Does it give you any idea? Liquation. What do you think? Yes, Ayush? Refining with the help of a liquid. Any other thing? Anything else which is coming?
Refining by converting.
Okay, very good. Refining by converting it into a liquid. And that is exactly what your liquation method is all about. Now this method is used when the melting point of a metal would be lower than the impurities. Okay? In your impure block, the crude metal, we won't call it as impure metal, we will refer it to as a crude metal. Crude means itself containing some amount of impurities. We don't know what the impurities are. Alright, now the crude metal will contain some impurities. Now here what is happening is that the metal is having a lower melting point. Alright, and most importantly your impurities are not miscible with. So the major point we need to remember is that the melting temperature of the metal is lower than that of the impurity, and the impurities are not miscible with the metal. Alright, what do you mean by miscible? The word miscible? Anushka?
One liquid does not mix with another liquid.
Okay, very good. Okay, we are already knowing the concept of miscible and immiscible liquid. So even after you have got both of them in the liquid state, the impurity and the molten metal will still not mix together. What are the metals that we can probably separate by this? Bismuth, tin, lead, mercury, etc. Because all of them are having low melting point. This diagram will give you a better idea as to how exactly your purification will take place. This is a furnace, alright, wherein you can see that there is a sloping curve. The impure metal which you are having, any either tin, lead, bismuth, etc. we can quote from here that the charge, we call it sometimes as the charge. The sloping curve. Now what is happening is that from here you will heat you will maintain the temperature in such a manner that only the melting point, okay, you will keep in mind the melting point of the metal which you are going to purify by this particular method, and we will just keep it just a slightly above, very very little above the melting point of the metal which you want to purify. You will maintain the temperature. At this point what will happen, the impurities are anyway, they will not melt, and even if they are melting, the impurities are immiscible with the molten metal. Alright, so the sloping floor of the evaporated furnace is used to melt the crude metal when the pure metal will flow down. Alright, the temperature over here is just slightly, very little above the melting point of the metal. The metal starts melting, pure metal will start melting, it will flow down. We can collect it over here as a pure molten metal, and after that we can use it for whatever purposes. The impurities which are there, which are anyway not miscible with the molten liquid, they will be left behind on the sloping curve. Once the entire pure molten metal has been obtained, we can remove the impurities separately, and then we can put another batch of impure metal over here, and the same process continues. So what is the basic principle which we are using in this entire method of liquation? What is the main principle which we are using? Yes? Difference in the melting point of the metal and the impurity. Difference in the melting point of the metal and the impurities. Okay? Second method which we are seeing is distillation. Kindly take this down. Second method, please put the number properly. Liquation is the first method, distillation is the second method. Only the first point. Only the first point. That's it. For what are we using this? Underline the word volatile. Also take down the kind of metal which we can separate. What do we understand by volatile? Only the first point and that's it. Stop writing. Volatile. Evaporates. Very good. Alright. So what we are doing over here is that you will be taking the, again, of course we are having crude metal, means the metal is having some impurity or the other. But the fact over here is that the metal can evaporate very fast or it can go into the vapor state very fast. What is the other thing that I can say about the boiling point? Low boiling point. So the metals which can evaporate faster, which can go into the vapor state very easily, very quickly, or which are having low boiling point, for example zinc and mercury. Here what we can do is we can take advantage of this particular low boiling point and we can use the method of distillation. We can distill the pure metal out, leaving the impurities behind in the distillation flask. So the main thing over here which you are using is the boiling point has to be lower than their impurities. Okay, and your metal which are able to evaporate very fast are zinc and mercury. So what we do is the metal to be refined is heated just above the boiling point, just above the boiling point, and after that the impurities obviously will not vaporize because the impurities are having a higher boiling point. Fine. The pure metal vaporizes and after that we will be condensing the vapors of the metal and whereby your impurities are going to be left behind in the distillation flask itself. We'll have a look at the okay. Now here children, this is a diagram which will give you a better idea. We have a distillating flask with a mixture with a heating retort over here. In this we have a crude metal which we are melting. What is the temperature which we are maintaining over here? Should I heat it? At a very high temperature, low temperature, what temperature? Someone who has not answered. Okay, Anirudh.
Just a little bit more than the boiling.
Just a little bit more than the boiling point of impurity or metal? Of the metal. Okay, at that point what will happen to the metal? What will happen to the metal which is present in the crude block? This is girl in first bench. It will turn into the gaseous form, vapor form, or the metal will vaporize. Once the metal will vaporize, it will enter into the condenser. What is the function of the condenser? Function of any general function of the condenser. Here, Anveshi, to condense the vapor and bring it back to the liquid form. Right. So this is what exactly your condenser here will do. The pure molten metal vapors which are entering into the condenser will be condensed, brought back into liquid form, because obviously your metal is much more volatile than the impurities. The distillate is richer in more volatile component. More volatile component means which component? Impurity or the metal? Metal. Which kind of metal? Pure molten metal which is volatile in nature and which is collecting back. So in this manner you can get your molten metal by simply making use of the physical constant. Physical constant means here we are making use of the fact that the metal can vaporize very easily. It can get back into, your metal will have a very low boiling point. Any doubt in liquefaction and distillation? Any doubt in liquefaction and distillation? Any question? Clear? Can you go ahead, class? Okay. Alright, this is now exercise for you. Distinguish between liquefaction and distillation. In your notebooks you can do it. After that I can take the answers from you. Right now, distinguish between distillation and liquefaction. Any 2 points. Any 2 points. Quickly. Should not take more than 2 minutes. If you have understood the concept, you should be able to distinguish. 1 minute more to go. Have you finished? Good. Prashant, sit straight, please. Finish, Bhagesh. Karan. Shall we discuss the answer? Yeah? Okay, stop writing. I think 2 minutes are done. Stop writing. Put your pens down, please. Stop writing, everyone. Okay, just tell me that on the basis of what have you distinguished, first of all. What are the 2 points which come to your mind when you think about equation and distillation? Yes, you? Yes? No, just tell me the points on the basis of which you are distinguishing. Don't tell me the exact distinguishing. I don't want that. Sorry? Liquid and gas. You mean to say the state. Okay. Anything else? No, not Karan, not you. Please. Somebody else. Okay, Anushka. Only the point on
The difference in the difference in the properties, which properties are different.
Okay, very good. Yeah, and that's only first point. Is there no second point to distinguish? Yes. Okay, yes. To what it is? Okay, to which state you are converting the impure metal into? Alright, fine. Yes?
Boiling point, like in equation, there is the boiling point is more than the normal boiling point, and in distillation there is only just little bit more than the boiling point.
Okay, so you make us talk about the temperature. Basically, whenever you talk about distillation and equation, you are keeping in mind the temperature and what the state, that is from the impure metal solid state, which state you are converting it into. Can anyone come and write the first one to distinguish? I know there is one more point, but at least let us finish with the first point. Now, Ayush. Okay, very good. That is the second point which I think Krishna wanted to say. No, one more. Okay. Okay, the place, furnace, agreed, and here is the distillation. But it is not the distillation apparatus which is shown over here. It would be an iron distillation apparatus, and the apparatus is much more bigger, and it's an industrial setup. Okay, because we will not carry out distillation of impure metal in a laboratory setup like this. So that you will have to keep it in mind. Yes? Okay, yes, we have already taken that point, I guess so. Yes? Okay, miscible. Examples of what kind of metals we can separate by either of the methods. Who can come and write the first point? Krishan? First point, very quickly. Second point, Emil, and we finish it. Correct? You will all check whether you are written properly or not. First point is the definition or the principle that what is the main thing which you are using in liquid equation. And the second point would obviously be that what kind of metals I can separate. Third point, as all of you have told me, that yes, fine, this is taking place in distillation apparatus. Here we are using a laboratory furnace. And the fourth point, you can talk about the states. That from solid to the melted to the molten liquid, or otherwise you can say from the solid to directly to the vapors of the metal. So total we can have 4 points of distinguish. Okay, good. Please make corrections if anybody has made a mistake. Yeah, difference in temperature is there. Give yourself a good first, a small tick if you have got the first point correct. How many got the first point correct? Raise your hands. Those got the first point correct. Good. the color. Pick any other color. Red, green, blue. Okay. Types of metal which we can separate by equation. Okay. Write down. Difference in the temperature is more than Sishan, both the points are same, isn't it? What we are written. It is based on the difference of the melting point of metal and impurities. It is based on the difference of the boiling point of the metal and impurities. Where is the distribution? Metal and impurities and melting point of metal and impurities. Okay, melting point and boiling. Fine. Good. Temperature is more than the boiling point of boiling point of boiling point of what? Of impurity. Slightly, no? Okay, tell me just orally which metals can be separated by the equation. The one which are having low melting point, like. Okay, write down please. And distillation, that's the third point. For distillation, you will be having zinc, mercury, annual equation, tin, stevie, lead, bismuth. Okay, write down any two metals quickly, and we wind up with your distinction between equation and distillation. What? That agreement I didn't know. Please write quickly. Equation Sm, Bi, okay, that is tin, bismuth, lead, and then you will write down zinc, even cadmium. You can also write down cadmium, mercury, zinc over here. That is for your distillation. Distillation, zinc, cadmium, mercury, here tin, bismuth, lead. Right? So total 3 points in the examination. If we ask you, then based on the points given the bracket, kindly write down properly. Yes, yeah. Oh yeah, zinc, mercury, cadmium. CD. Zinc, mercury and cadmium. Yes. Gallium can be separated by distillation. Yes. Yes. Very good. A large number of, we go to your third method of separation, electrolytic refining. Electrolytic refining, give the heading please. Kindly make a note. Before I actually go about, we will just quickly see a small animation after that. Just give the heading and have a look at the video.
It contains dissolved metal ions. This causes the dissolved metal ions to deposit on the electrolytic refining of copper. Electrolytic refining is a process of obtaining pure metal by the process of electrolysis. In this method, an electric current is passed through the solution of electrolyte that contains dissolved metal ions. This causes the dissolved metal ions to deposit on the electrically charged cathode. Let's see how pure copper.
We'll look at the process. After that, we again go about the explanation.
Taking impure copper as anode, then thin sheet of pure copper as cathode in an electrolytic cell containing NSN5 solution of copper sulfate as electrode. When you pass an electric current through the electrolyte, you can observe that copper from the impure copper anode gets dissolved in the solution as CO2 plus ions. These ions get reduced to copper at the cathode get the positive polarity. On the other hand, the sulfate ions migrate to its pure copper anode and combine with the developed copper sulfate, which goes to the electrolyte. Alternatively, the less electropositive fluid will settle down as anode fluid. The reactions involved in this process are shown here. That is, the Cu2 plus ions from the electrolyte reduce and deposit Cu at the cathode. Similarly, at anode, the Cu from impure anode oxidizes and forms Cu2 plus.
Okay. What do you mean by electrolysis? You have done an entire chapter on electrolysis. Definition of electrolysis. Electro means electric current. Lysis means to break. Okay. With the help of passage of electric current, we will break up the electrolyte. Alright, and after that entire into its constituent ion. Very, very good. Now, children, here what we are going to do is that we use the principle of electrolysis, but we are using it for refining of metals. Now, as you can already see that what are we refining over here? Which metal are we refining? Okay, copper. Please raise your hands. Alright, we are refining copper. What is anode?
This anode is the negative ion.
Anode is the
Positive, and the cathode is negative.
Alright, anode is the positive terminal and cathode is the negative terminal. This is clear? All of you all, anode is positively charged, cathode is